Algebra tiles can be used to solve certain quadratic equations. They are a hands-on model that makes solving certain quadratics simpler. In this video, we'll be using algebra tiles to solve quadratic equations. Let's start with an example. The area of this square can be found using this quadratic function, y equals x squared minus 2x plus 1. Use algebra tiles to find the binomial form. Using algebra tiles to solve a quadratic equation is similar to the technique of completing the square, where we turn a quadratic into the square of a binomial. Let's start by modeling the quadratic with algebra tiles. Here is the quadratic modeled with tiles. Let's rearrange these tiles into a square shape. This collection of tiles easily rearranges itself into the binomial negative x plus 1, quantity squared, which can be rewritten as x minus 1, quantity squared. Let's look at another example. The area of this rectangle can be found using this quadratic function, y equals x squared minus 4x plus 2. What minimum value for x guarantees a non-zero area for the rectangle? We'll model this quadratic with algebra tiles and try to form a square shape with the tiles. Here are the tiles that model this quadratic. Now let's arrange them into a square. In order to complete the square, we have to add 2 additional yellow tiles, which means adding 2 negative tiles here so that we don't change the value of the left side of the equation. The square models negative x plus 2, quantity squared, and here is the numerical term. Because we're dealing with a square, this is an equivalent form, and moving the negative 2 to the other side of the equal sign gives us this equation. Finishing up the solution, we get these terms, which results in 2 roots, x equals 3.41 and x equals 0.59. If we look at the graph of this function, you'll see that there are 2 areas that have non-zero areas. There is this section from x equals 0 to x less than 0.59. Then there is this section where x is greater than 3.41. This area here has negative values for area.